Hello again to Joma Simplified, and today we want to look at how to obtain the integral of this quite simple but a little bit trickish integration problem. Let's look at it together. The question says obtain the integral of the square root of 1 plus 2 sine theta cos theta d theta. Okay, so to obtain this is actually quite simple. All you have to do is recall some basic trigonometric identities. And what is that trigonometric identity? The trigonometric identity is this. We need to recall that sine square theta plus cos square theta is always going to be 1. Going to my integral, wherever I see 1, I replace by saying sine square theta plus cos square theta. So this becomes integral of the square root sine square theta plus cos square theta plus 2 sine theta cos theta d theta. Of course, I can rearrange and say integral of the square root of sine square theta plus sine theta cos theta plus sine theta cos theta plus cos square theta. All I have done is separated this instead of saying 2 sine theta cos theta. Just sine theta cos theta sine theta cos theta. Of course, when this adds up again, it becomes 2 sine theta cos theta. But the reason why I'm doing this is so that I can be able to factorize, because I noticed that sine theta is factorizable at this point and cos theta is factorizable at this point. So I factorize. This becomes integral of the square root. Sine theta is common, so I take away sine theta, sine theta. What will be left here is sine theta plus cos theta plus cos theta is common, so I factorize cos theta. This becomes sine theta plus cos theta. Oh, I forgot my d theta. Okay, so I notice again that sine theta plus cos theta is also common, so I can still factorize. So this becomes integral of square root sine theta plus cos theta. When I factorize sine theta plus cos theta, what I will be left with is also sine theta plus cos theta d theta. So I notice that sine theta plus cos theta is common. So instead of just saying sine theta cos theta, sine theta cos, I can just say this becomes the integral of the square root of sine theta plus cos theta all square d theta. And of course, square can take care of my square roots by cancelling each other. So this becomes the integral of sine theta plus cos theta d theta. Of course, the integral function is a linear function, so it can just go in. This becomes integral of sine theta d theta plus integral of cos theta d theta. Integral of sine theta is minus cos theta plus the integral of cos theta is sine theta plus my constant c, and that gives me my answer.